In this video, we're going to look at the second case of logarithms and non-linear data. So the second case is when we have an exponent involved, as in the power of x. So let's take an example from October 2020, the AS paper. An advertising agency is monitoring the number of views of an online advert. The equation is given by log v is equal to 0.072t plus 2.379. is used to model the total number of views of the advert v in the first t days after the advert went live. Show that v is equal to ab raised to the power of t, where a and b are constants to be found. Don't forget, b to the power of t is an exponent. So this is case number 2. So what we do for a case like this is we would write it out as the following. So we can say case number 2. So in our case, we want v is ab to the power of t. So we want it in this form. So what we can do is to apply logs on both sides. So it's log v equals to log of a b to the power of t. So that's going to give me log v, applying the laws of logs here, log a plus log b to the power of t, which is log v is log a plus t times log b. So now that's in the form of y equals mx plus c. So if we write our equation down, we've got log v is 2.379 plus 0.072 times t. So we can see the following, that the log a corresponds to 2.379 and that log b is in reference to 0.072. So what we can do is to anti-log both sides. So 10 to the power of a log cancels out, so I get v is 10 to the power of 2.379 plus 0.072t. So we get v is 10 to the power of 2.379 times 10 to the power of 0.072t. So we can say that 10 to the power of 2.379 will give me the following. It will give me 239, rounded correct to 3 significant figures, and 10 to the power of 0.072 will give me 1.18, correct to 3 significant figures raised to the power of t. So now I've got my equation in the form what they want. For part B, it says interpret with reference to the model the value of AB. So we're going to say the following, that the value of AB is the total number of views of the advert one day after the event went live. Part C says, using this model, calculate the total number of views of the advert in the first 20 days after the advert went live. Give your answer correct to 2 significant figures. So we can just say v is equal to 239 times 1.18 raised to the power of 20. Then on my calculator, that will give me 6,546.935 and so on. And that is equal to 6,500 rounded to 2 significant figures. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So in this question, what we're going to do is write down what we have. So we've got v equals to p q raised to the power of t. Apply logs to both sides, so we get log v is log of p q raised to the power of t. So we can apply the laws of logs. Log v is log p plus log q to the power of t. So log v is log p plus t times log q. So now that we have that, we can write down what they have. So we've got log v is 4.8 plus 0.05 t. So now what we're going to do is we're going to anti-log this. So it's anti-log both sides. So we get v is 10 to the power of 4.8 plus 0.05 t. Use the laws of indices here. So that's times 10 to the power of 0.05 t. So we get 10 to the power of 4.8 is 63095.73 and so on. So, and we're going to times that by 10 to the power of 0.05. So that's going to give me 1.122 raised to the power of t. So we can now say that we want it in the form of what they've given us. So we can say that v is p q to the power of t. So p in our case is going to be 63100, correct to 4 significant figures. And then we can say that q is 1.122, and they've both been rounded to 4 significant figures as told in the question. And then it says, with reference to the model, interpret the values of p and q and find the value of the painting as predicted by the model on the 1st of January 2010, given your answer to the nearest £100,000. So what we can do now is say that for p, so p is the value of the painting on the 1st of January 1980. And that q is the proportional increase in the value of the painting each year. Of the painting each year. And then for part C, we can just substitute it into our equation. So 63100 times 1.122 raised to the power of 30 gives me £2 million.